Hi, this is Ms. Hogan. Today we are going to discuss compound inequalities. So just like when you were learning about how to write a paragraph or a sentence, you may have heard about compound sentences, which help you join together two shorter sentences. Similarly, with inequalities, compound inequalities are two inequalities, and it can actually be more than two, that are joined together with the words and, or, the word or. So, for example, like if you're thinking about this in the real world, this could be something like when you're talking about someone's age that they're likely not working. You would say something like, okay, people who are not working, this is a generalization, but like if you are less than 18, younger than 18, or if you are older than 70, let's say. So those are two things that like would never intersect. They're either or. You're either younger than 18 or you're older than 70. Those things are never going to be the same number. So same thing is true here with our solutions. You're used to seeing just one inequality at a time. The or compound inequalities are going to have two separate inequalities like you can kind of see down below here. And I'll get to that in a minute. So this example is already solved for you. So once you have your solution, you would have something like x is less than or equal to -2 or x is greater than 3. So the solution is really just to graph it. So we have a closed circle above -2 pointing to the left, and then we have our open circle above 3 pointing to the right. And that's sort of it. So when you're asked to solve something like this that is compound, it would include the solutions to both inequalities and two different graphs happening on the same number line. And that's kind of it. Now you may be wondering what this interval notation means. So interval notation is a way to sort of like write your answer, and we're actually going to skip that in this unit. So wherever you see interval notation, we're going to go ahead and skip it. Let's get into some examples that have a more like full start to finish way to solve this so that you can have some practice with that. So this says solve, graph, and then write the solution in interval notation. So again, we're just going to do the first two parts. No interval notation needed. So as you can see, the way that it looks different from what we've been practicing so far is that you have two inequalities. You have one on the left that says x minus 4 is less than -7. And then our inequality on the right says 2x is greater than or equal to 12. And we're just going to solve those like normal. So on the left, I'm going to have adding 4 to both sides as my first step. That's going to leave me with x is less than -3. Over here, I have 2x is greater than or equal to 12. My first step is to divide both sides by 2, which leaves me with x is greater than or equal to 6. So when you're writing your solution, if you're not using interval notation, which we are not, you would just use the word or. So you would write something like x is less than -3 or x is greater than or equal to 6. And like I was talking about in the example with the age, you'll see when you graph this one, I'm going to use two different colors. So I have x is less than or equal to -3. That's going to be here. And then my other one is x is greater than or equal to 6. So that is a closed circle pointing to the right. What I was going to say is you'll see that like they're not intersecting. There is no number that meets this criteria that also meets this, which is kind of like what you're talking about with how old people are when they work as a real life example. That's kind of it for or. I would say or is definitely the easier type if we're talking about or versus and, which we're going to talk about in one moment. Let's give you practice with one more. Go ahead and try number 5 on your own and come back when you are ready for the solution. Okay, so my first step with this one on the left is to distribute the -3. That's going to leave me with -6x minus 3 is less than -15, adding 3 to both sides. That's going to leave me with negative 6x is less than negative 12. Divide both sides by negative 6. That's going to leave me with x is greater than, sign flip, 2. For this one over here, we have 1 minus x is greater than or equal to 5. So we're going to subtract 1. That's going to leave me with negative x is greater than or equal to 4. I need to divide by 1 to make x, or negative 1, excuse me, to make x positive. That leaves me with x, sign flip, less than or equal to negative 4. Okay, so when I'm graphing, you don't have to do it in two different colors, but it's just kind of helpful. So we have x is greater than 2, and we have x is less than or equal to negative 4. So again, we're showing numbers that are less than or equal to negative 4. Okay, that's it for or. Flip your paper over and let's talk about and, which is kind of the more complex. So and inequalities have a tendency to graph together. And we call this the intersection. This is where they overlap, which is the solution. So going back to that example about ages. So if we're thinking about like an age that you have to be for a discount, let's say a student discount requires that a person is at least 13 years old, but younger than 22, assuming we're talking about like college students. So that's going to have a lot of overlap. It includes people who are older than 13, but younger than 22, which includes a lot of the same numbers. So as you'll see, as we're practicing these, they have overlap and the graph is going to look slightly different. So in this example that we have here, again, this is like a solved one, and I'm going to show you how to graph it. So we're left with x is greater than or equal to negative 6, and x is also less than or equal to 1. I'm going to use two different colors for this. So first I'm going to show x is greater than or equal to negative 6. And it's going to be heading this way. Now, normally we would draw this arrow and call it a day, but I'm going to hold off on that for a second. I know it's going to be going this way to the right. And then my next one is x is less than or equal to 1, which is going to be going the other way. And check it out. They're going to intersect here. So this area of my number line is where all of the solutions lie. So again, this is the solution. Okay, so because the solutions to an and inequality fall between two endpoints, meaning like here, like we just talked about, they're frequently written in a more condensed form. So you can write it like this and it would be considered correct. You can write it the long way. So let's take an example that we were just using as like x is greater than or equal to negative 6 and x is less than or equal to 1. That's kind of how we were doing it up here with the ors. So your solution is like both of those with the word or in between it. Down here, the more condensed version would be something where x is in between the two numbers. I like to start with the x, and I'm going to include my signs like this, and I'll revisit this in a moment in case I lost you. Looking here, this says x is less than or equal to 1. So one of my solutions, part of my solution, is x is less than or equal to 1. The negative 6 is going to go over here, and you might be thinking, well, like, wait a second, Ms. Hogan, this isn't communicating the same thing here. But it actually is. As you will remember, we've been talking about how helpful it is to have the variable on the left-hand side because we read from left to right. So if I were to rewrite this part by itself with the x on the left, it would say x is greater than or equal to negative 6. So this is communicating the same thing. And essentially, I like this way because it's also making it really clear that x is between these two numbers. So be careful because typically it's easier if you keep the number that is the lowest value on the left because you're saying x is between the lowest, the least, and the greatest. Okay, we are going to try two more together and then I'll let you have some independent practice time. So number 6 is an example of what you'll see when you're solving and compound inequalities. Now, this looks crazy, right? It looks a lot different than how we're used to seeing it. The ors, you had two separate inequalities and then you solved them. But don't worry. Basically, what this is saying, I don't want you to write this down, but I'm just going to show you. This is basically saying this. And it's also saying, so again, this is the in between, kind of like if you think about like what we were just doing with our solution, and then that way we're able to represent both inequalities. So don't worry, it's not going to be that crazy. I want you to pretend like this 2 is not here for a moment. So if we saw just this, what would be the first thing that you do? You would be subtracting 4 from both sides. I'm still going to do that first. I'm going to subtract 4 from both sides. Okay, now that's not our reality. So we have this other situation over here. Similarly though, if I'm just thinking about that inequality, I would still do the same thing. I would still be subtracting 4, but I also need to subtract it over here. I'm going to show you that with another color just so we can kind of keep track. So my first step is the same. You're just doing it in an additional location. Okay, so that's going to leave me with -2 is less than or equal to x, this is gone, is less than 5. What this is saying is x is between -2 and 5. And I'm going to show that now. So again, thinking about your symbols and what goes where, this, if it helps you to write, so all the, this is your solution. If it helps you to rewrite it, like, so especially as you're first getting used to it, you're basically just taking this part so that you know what symbol goes where. So I'm looking for x is greater than or equal to -2. -2 is here. It's going to be filled in. I know I'm heading this way, but I'm going to wait and see where I end up. The second part of my inequality solution is x is less than 5. That's going to be above 5, and our intersection is here. You don't have to do 2 colors. If it helps you though, you're welcome to. And that's it. So our solution is both shown in our answer here and in our graph. Okay, let's do one more together, and then I'll give you some independent think time. -27 is less than 7x minus 13 is less than 8. So again, looking at this, what's stopping me from having this variable by itself? A few things, the 7 and the -13. I'm going to start by adding 13 to both sides and also over here. That's going to leave me with just 7x is less than 21. And over here, I'm going to have -14. Okay, take a brave guess at what our next step is. If you said divide by 7, you are so right. We are going to divide by 7 on all areas of our inequality. That's going to leave us with -2 is less than x and less than 3. Okay, so then when it's time to graph it, I have an open circle above -2, and I have an open circle above 3, and the intersection is here. Okay, would you pause this video and pick one more inequality, a compound inequality, to solve and graph between 8, 9, and 10. Pause now and come back in a moment. Okay, welcome back. I'm going to show you the solutions to 8, 9, and 10. Number 8, the solution is -4 is less than or equal to x and less than or equal to 2, and our graph looks like this. Number 9, -3 is less than x and less than or equal to 6, and this is what our graph looks like. Number 10, 5 is less than x and less than or equal to 8, and this is our graph here. Thank you for your hard work. I hope you have a great rest of your day.